Now that we have all those files put into our Jupyter folder, again, we'll be able to run through these and sort of work through basically some of these main ideas within Python programming language. The first one we're going to start with, and as you can see, these are numbered from 1 to 4, goes to one.variables. I've already opened it up right here. One thing I'll make a note of is the fact that one of the nice things about these Jupyter environments is the fact that you can actually embed something called Markdown. This is an additional language that adds basically some text and some images and some links and things like that, basically to create these documents to be a little bit more human readable. So a couple examples going through here. And again, you can add things like images, you can add things like LaTeX as well, so you can add equations as well. And so these documents become a lot more richer in terms of not only just having the code available, but also having the ability to see that you can actually embed things like additional images and things like that. First thing we're going to see is the fact that you might want to actually add comments directly into some of these pieces of code. In Python, we'll start right here, basically you're going to use the pound sign or the hashtag or that particular symbol to actually add comments within these environments. Again, within the Python environment, this will basically never run. And so if you're coding, so let's say 2 plus 2, the 2 plus 2 part will run, but the parts that have these symbols attached to them basically will not run. And this helps to sort of let you sort of add comments to your code so you can sort of go back to them and look through and sort of see what you were thinking about at that point in time. Or if you want to sort of comment out a particular part of code and make sure that it doesn't run the next time that you go through it. Next, basically, is going to go through some of the ideas of some of the variables that are available through Python. Variables are basically stored values or data within these environments. One thing I'll make a note of is the fact that some other languages, C, I want to say Java as well, basically you have to declare what type of variables these are. In Python, you don't actually have to declare these. Python will sort of intuitively sort of put in what their actual sort of types are specifically. So if we're creating, let's say, an integer or a whole number, my example here is just a variable called SumInteger equals 0. So if I run that, nothing exactly is going to happen for that, but we can also print it, SumInteger, and run that, and you'll see that the current value for SumInteger is equal to 0. And again, I didn't have to say this that SumInteger was an actual integer. Python sort of intuitively knew that because it's a whole number, it's going to be set as an integer for us. A function that is built into Python called type, and as you can see here, type with the brackets around it. If you run this, this will actually tell you what type of variable it is. I typically don't use this very often, but just in case you're kind of wondering when you're going through a program what type of variable it is, you can actually use that function to see that particular value. Next, we're going to show how we can just add some another whole number to this. So right now I have SumInteger is now going to equal its original value plus 10. And then it's going to print that out again. So if I run this, it's going to say 10. If I run it again, 20, and 30, and so on. Now, as you can see here, if you look at this next line, I have not run this line yet. So right now it still says 10. Basically, we have to run this cell to get the updated values because, again, these are sort of independent of each other, these cells. So if I run this, it should say int and 30, which is currently the correct value. Next, we're going to move on to floats. Floats are basically more precision than integers, obviously. They're floating points, basically. To declare one of these, all we need to do is have a new variable. So in this case, we're going to have SumFloat is the name of my variable, equal to .0 or 0.0. And that just, again, sort of clues Python into the fact that this is going to have more precision than just a whole number and makes it a float appropriate for that. Let's say we made it 1.0. It'll make it 1.0 for us. So I'm going to set it back to 0 for now. Again, we can do the same thing as before with what we did with SumInteger and just add 10 to it, maybe a couple times. And we see that it increments by 10. And again, it's going to use the precision that we had specifically for float. So as you can see here, even though I'm adding a whole number to it, it's going to be 20.0. And type is going to be float as well. For the most part, when you're mixing integers and floats, things will work as they should, except for one scenario, and I'll kind of get to that here in a second. So if I add SumInteger to SumFloat, let's run all this real quick, we're going to see that we originally had integer as 20, and some float is, some integer is 30, some float as 20, we get 50.0 here. So it's going to take the precision of the highest value, if you will. So that's why some float is being utilized and it says 0.0 instead. We can add 0.1 to some integer, and we get 31.1. But one thing you might notice here is the fact that, actually we might have to, for this example, I'm actually going to add a little bit more to some integer to actually show this. So some integer equals some integer plus 1. There we go. Now that what you see here might be something that might look a little off to you. In this line here, we're going to see that when we print some integer, it's currently listed as 31. But when we divide by 3, another whole number, we get 10. You'd assume that because of the fact that, if it's 31 divided by 3, there would be some sort of precision, so, a decimal point afterward, 1/3. The case is the fact that whenever you're using a whole number or an integer divided by another integer, it's just going to keep that precision. So that's why it gives you 10. And it's always going to round down to the lowest number. So as you can see here, we have a situation where we're not getting specifically the right value for this. What we need to do is actually divide by some integer divided by 3 point. And that basically says, let's make sure we have that precision. And that's why we get the correct value here, so 10.33. Another thing you can do within variables is do something called typecast. Typecast basically sets it so you can sort of specifically specify within Python what variable type you would like to have. Again, printing out some integer and some float. Let's print all this out. We have 31 and 20.0. Let's say we wanted to make integer a float value. We specifically tell it, use this function called float, and now it's 31.0. Or some float, we want to make it an integer, we say int. Again, this is a built-in function for Python, and it turns it from 20.0 to just a 20. And this is another way to sort of solve that problem we saw earlier. So we have some integer. This time we're going to declare it as a float, and then divide by 3. And now we're getting the correct 10.33 at this point. Another type to utilize within a variable type within the Python environment is something called strings. Strings are basically a sequence of letters, numbers, special characters, spaces, returns. Basically, they're just a string of alphanumeric values. For our example, I have hello statement, so I'm going to run that real quick. And if I look at that, we're going to see that is a type string, and it's going to print out hello everyone with an exclamation point. Now, in some languages, C in particular, sometimes you will have a situation where there's a difference between a string and a character. In Python, they're treated the same. So a single character, like this, is still a type string. So again, there's no difference between a character and a string specifically. Let me run that. Next, we're going to go through indexing and slicing and basically what things you can do with strings. And this becomes a bigger point basically as we're moving forward with like parsing files in that regards. So in this, I'm running hello statement, and then I'm using the brackets 1. And it should be printing out the first character in our string. Basically, intuitively, you'd assume it would be the first character in the string. Now, you have to remember that within most programming languages, actually the indexing starts at 0. So the reason why you see for 1 gives us the second letter, the letter E, we actually are looking at the second index. So if I go 0, I should get the letter H. So again, a lot of times, and this is true of a lot of programming languages, is the fact that we're going to start at 0 for our indexing. If I wanted to print the first 5 letters, I would use this. And it would actually print off 0, 1, 2, 3, and 4. It cuts off that last 5th digit, if you will. So basically, it's inclusive on the left-hand side, just so it starts at 0 and it stops at the 5th, basically. So even though these are the 0, 1, 2, 3, 4 values of those indexes, again, looking up here, it's going to cut it off at that 5th one. You can write this same statement here using this particular language here. So basically we're dropping off the 0 part. Or if you want to drop off the first 5, you use this type of statement. So it's 5 : and then basically nothing afterwards. There are a lot of built-in string functions when it comes to from Python. Things like find, which will actually let me do this, print oops, print hello statement. So here's our original statement, hello everyone. If we wanted to find the word 1, we run this particular find function, and it's going to tell us it starts at the 11th index of that statement. So it's going to be right around here. If we run something that is actually not in this particular string, so in this case the word me, which does not appear in this string, it's going to give you -1, just to tell you that no, it's not found. You can capitalize, which capitalizes the first part of your string, lower, which lowercases everything, or we can use something that's more actually utilized than pretty much all these other statements, but this is called split. And split creates something called a list, and we're going to get to that in a couple seconds here. Split basically takes the string and splits on a current value. In this case, we're splitting on the space, and so we have hello in one part of the list and everyone at the second part of the list. Let's change this to the letter E, and so now it's going to split where we see the letter E. We're going to see it's going to have H, LLO, and then basically it's going to sort of break this all apart from there. Wherever it sees the letter E, it's going to split this particular string. Let me set it back to a space. So another thing you can do for this is basically is chain a lot of these together. So let's say you wanted to, for some reason, capitalize the first word and then lowercase everything. You can do that and it will work from left to right. A better example might be something like this. Let's say we wanted the first 5 characters of the hello statement and then capitalize it, so the word hello. So you can actually chain all these together. And it makes it nice because if you have multiple statements, and let's say we wanted to add one more, split on the letter E. So there it goes. So you can kind of work from left to right in this regards. Let's move this for now. Another thing you might want to do is actually concatenate or put 2 strings together. In this case, I want to take the string course name and the string course number, and again I'm using these the parentheses. So basically, this is going to be looked at as a string in this case. And if I just add these by using the plus sign, you're going to see that it's going to concatenate those 2 together. Another way to do this, and basically what I would recommend doing, kind of moving forward, even though it's not the most intuitive in terms of what it's actually saying, is to use this type of method. What's going on here is we're using our %s basically, and this is basically sort of setting a placeholder for a value. So the string is sort of over here, and what we have to feed into it, and again we have another % sign right here, and then we feed it in certain values. So in this case, it's going to say, all right, I have 2 places, %s, that I'm looking to have values put in. So over here, I have course name, course number, and it prints out Bio 101 for us. Let's say we change this side over here and put a comma. Now the nice thing about this is the fact that we can focus in on this left-hand side as the format of what we wanted sort of for our output, if you will. Let me set it back, and now it says Bio 101 again. And this actually helps a lot in terms of, let's say you have multiple variables you're trying to print out. Let's say we wanted to take these 5 variables, which are basically strings, variable 1, 2, 3, 4, and 5, and print them so they're concatenated together using commas in between them, so like a comma separated value. If we can do this one of 2 ways, and this is sort of the traditional way, so we have variable plus comma plus variable 2 plus comma, so on and so forth. Now this works fine for this situation, but if you can imagine having multiple, maybe another 5 or so variables or 10 or something like that, having lots of variables in this regard, or strings that you're trying to concatenate, this can get very sort of long in terms of its sort of how you're sort of presenting it. So what I would recommend is using the second way that I mentioned, using the %s, comma, %s, comma, so on and so forth. So I have 5 values here, and it's saying I'm looking for 5 strings. And so now I feed it in those 5 variable names, and it produces the same output. Run again. And again, this lets you sort of focus in on the left-hand side being the format that you're trying to output, and then just feeding in variables on the right-hand side over here. Now, if we wanted to, we could actually set this to be an integer, and it still works. Basically, it's just going to read this number 2 in as a string in this regards. So we see it still works. Set it back. So you can actually sort of concatenate strings within strings, if you will. So this print statement down here. So let's say we have course name and number. So I'm setting it equal to the %sign s, and feeding it the name and number. And if we print that, we're going to see Bio 101. And now I can go through and say, I am currently sitting in this particular course, so %s, and feed it that course name and number, and it should say, I am currently sitting in Bio 101. Next, in terms of variables, is booleans. Basically, this is your true, false, 1, 0, yes, no kind of situation. You can explicitly say to sort of set these by doing something like setting a variable equal to true, and as you can see, true is, in this case, green. It's just sort of telling you that this variable or this value that you're utilizing is something that's preset within Python, and it sort of knows that, oh, this is going to be a Boolean variable. So if we look at the type in this case, we have a Boolean variable. Some of these statements I'm gonna kind of walk through, but we're gonna have more details on utilizing these booleans moving forward in the next notebooks moving forward. So in this case, let's say we had some condition which we currently set to true, and we have a condition statement. So in this case, it's saying is true double equal signs. That basically says, are these two equal to each other? Well, is true equal to false? No, it's not. So that's why it's producing the output of false. We change this to true. Oh, sorry, forgot to run this up here. As you can see, here's a good example of a situation where, because I didn't run this particular cell, it didn't actually have the value for some condition. So let me try that again. There we go. And now it's going to produce true, because some condition is equal to true. And now this statement is asking, is true equal to true, which is obviously true in that case. And again, we're going to see this moving forward a little bit more, but if, let's say, you have if statements, basically some conditions. So this first one says, if false, which basically means it's not going to run, it's going to print this value here. If true, print this particular value. So if we run this, it should print the if true statement. Next, we have something called lists. Lists are going to be sort of, a list of information. You can also think about these in terms of an array. And a lot of times other programs will call it that. Basically, it's just a list of data. Right here, I basically have there's a couple different ways you can actually create lists. In this case, I'm explicitly giving it values. So I have the brackets on each side and commas to separate each part of the list. So if I run this, basically it's going to have apple, banana, and egg. And if I want to, let's say I wanted to get the second value, print grocery list. And again, because 0 is the starting index, if I wanted to get the second value, I would use 1, and it should print banana. Another way to do this is basically saying to Python that we're going to declare this as an array. So grocery list equals those brackets. This basically tells it it's going to be actually I'll put it here, some type, grocery list. It's going to tell us, make sure I print it. It's going to tell us that it's a type list. And now what we can do is, instead of explicitly giving these values, we can just use the function that's built into Python called append. We can append these, apple, banana, and eggs, and print out this list again. Again, just to sort of make sure that we're clear on this, the index for a lot of these for most values within most programming languages, start at 0. And so if I do this, or I'm looking for the third value and the first value, or the second value within my grocery list, it's going to print those out. Now look at this last statement here. I'm looking at the third index or the fourth thing in my list. I get an error. Basically, there's nothing listed there. There's only 3 items. And because we're going over that value, it's going to give us an error that says this index is out of range. I'm going to run that real quick. And again, that's what we're expecting in this case. And then there's a more efficient way to sort of print through these values, and again, we're going to come to that later in terms of the notebook. The last one is last variable that we need to make note of is something called a dictionary. A dictionary basically uses 2 things. It uses a key and an index. In this case up here, I kind of wrote this out. Basically, so instead of using a number in this case, so 0, 1, 2, 3, 4, and 5, it's going to have the dictionary sort of use keys instead. So these are going to be like, some sort of specific value. So let's say our dictionary, we want to have the word, a value within our dictionary for street address. We would put this in the word street address, equal to 123 Apple Street, the value. So this is the key, this is our value. To declare a dictionary, we use the curly brackets. And now, again, this is going to let us know. I'll print this out. Print, type, personal information. It's going to tell it's a dictionary. And so let's go through this. So now I'm going to add a couple values. So street address is equal to 123 Apple Street. So the key is the street address. The value is 123 Apple Street. Key, first name, last name, or the value is Patrick, last name is Dudas, and so basically that kind of gives you an idea of the personal. Now we can sort of print those out. And so you can see here that it has a dictionary of terms for us. So last name, street address, and first name. One thing you might note is the fact that the ordering of this. Dictionaries don't have an order specifically. And so again, even though we started with street address, it's listed somewhere in the middle here. So that's something to keep in mind, is the fact that when you're doing dictionaries, you don't actually specifically hold an order. Again, there's a more optimal way to kind of print these values, but we're going to talk about that later in another notebook. So for now, basically, we've covered everything in terms of the variable section, and then we're going to move on to the second part of these workshops.